Good afternoon. Today's lesson is on decision matrix. A decision matrix is used to compare design solutions against each other using criteria based on project requirements. A decision matrix could be used to decide what type of option would be best to use to set up a prototype puzzle cube, similar to the puzzle cubes that I showed you earlier in the year. For example, if let's say we were to look at what material would be the best for creating, you've got 6 different options here. First idea is maybe modeling clay. Modeling clay is reusable. Okay, it's certainly readily available. It requires you to form it into cubes, though. It can be sticky, and the geometry is not quite precise. Another idea, maybe you could use caramel cubes. Ooh, yum, yum. All right, they're cheap. They're certainly readily available, tasty. Okay, they're pre-shaped. They're sticky, though. Okay, and their geometry can be a little bit imprecise. What about dice? Well, dice are expensive though compared to these other options. They're reusable though, it's advantage. Okay, they require two-sided tape. They're moderately stable, and their geometry is fairly precise. How about centimeter cubes? Well, they're relatively cheap. They're also reusable. They're interlocking, so you would need that tape. They have these little protrusions that stick out though that can kind of get in the way, but the geometry is very precise.
The next option is using foam blocks. Foam blocks can be expensive. An advantage, though, is that they're reusable. A drawback is that they require two-sided tape and they could fall apart easily, and also the geometry can be imprecise.
The next option, last option, option 6, is sugar cubes. Oh, yummy. Okay, sugar cubes are cheap. They're certainly readily available. You can get them in the supermarket. They require glue, so they can be a little bit messy, have these messy granules you have to clean up. And their geometry is fairly uniform. So let's look at what criteria we'd want to look at. Criteria could include cost, okay, reusability, geometry or the shape, how we connect these cubes together, how clean they are, resilience, meaning how long it's going to stay together before falling apart, and also testability. Can we test? Other criteria we might want to consider is the function, how well does it work, how long the product is going to last, how long it takes to develop, size, material costs, development costs. Cost is always going to be something that one is concerned when you're looking at important criteria. Manufacturing costs, company standards, manufacturing capabilities, and safety. Safety is always going to be an important concern. To develop our decision matrix, we're going to develop a grading scale. The grading scale we need in order to be able to assign values in order to compare or score different options. Some of them we're going to rank on a scale of 1 to 4. 1 being the worst, okay, 4 being the best. Kind of like a baseball or basketball score, the bigger number is better. And then a question scale, for questions, a yes or no ones, the no is going to be a 1 and yes is going to be a 2. So now we've got a spreadsheet here, just like Google Sheets, and we're going to go ahead and fill this out. Okay, the criteria we've chosen are cost, is it reusable? Is the geometry uniform? Does it self-adhere, or will we need something extra like double-sided tape? Do we need to clean up? Is the model resilient? And also, is it testable? And the options, again, are these 6 options that you already saw. And there's our grading scale along the bottom. So, all right, so first we've compared them all relative to cost. If you look, again, on a scale of 1 to 4, okay, the best options are number 4 interlocking centimeter cubes and also sugar cubes. They're certainly more affordable. And the worst is dice and foam cubes. They're more expensive. In terms of reusability, okay, they're all getting scores of 1 and 2, so they're all a little bit lower. Next, we score the uniform geometry. The best options here are dice and interlocking cubes. They both get a 4. And the worst option is modeling clay, which gets a 1. Okay, going on down the line, we've got self-adhering. They're all getting ones and 2s because it's a yes or no question. Okay, for cleanup, okay, interlocking centimeter cubes require almost no cleanup. Okay, whereas modeling clay kind of requires a little bit more. Okay, so we're ranging from a score 1 to 2. Again, model resilience, centimeter cubes look good. Okay, modeling clay and caramel cubes, not so good. And in terms of testability, Okay, there are your scores for testability. Now, once we've scored all of these, then we total them up. Okay, these totals should give us an idea as to what the best option is. So ideally, the best option would be the one with the highest number. In this case, interlocking centimeter cubes, number 4 has a score of 22. The poorest option is modeling clay, which gets the lowest score of 10. So based on this, idea 4 is the right decision. Decisions that we make should be based on analysis and logic, not personal opinion, which is why we came up with a number system to grade them, and we ranked them that way. A decision matrix can be used multiple times throughout a design process.